Hi guys, and welcome to Radioactivity lesson 3. First of all, let's have a look at the answers from last lesson's independent practice. That's the first slide. Again, make sure you're pausing, making any corrections you need to make. Here's the second slide. Okay. And the final slide. Okay. Once you've made your corrections, we're now going to move on to retrieval. Okay, same rules apply as always, guys. So let's start off with slide number 1. Slide, here's the answers. Slide number 2. Here's the answers. And finally, slide number 3. And here's the answers. Okay, now moving on to today's lesson. We're going to be looking at the activity of nuclei that are undertaking radioactive decay. Now, this is really important as we can use this information, okay, to look at the rate in which an unstable nuclei or an isotope decays. So, make sure we've got a pen and paper, and we're going to have a look at some new information. Okay, so what is meant by activity? What do I mean by activity? So, in this case, the activity means the rate in which unstable nuclei or isotopes decay. That's the activity, how active something is, how fast it decays. What unit is activity measured in? So you may not have heard of this before. It's measured in the unit known as becquerel. And the symbol we use is BQ. Now we also look at something called count rate. Okay, and count rate is the number of decays per second. Okay. Now, as I said before, we can use all this information in order to calculate activity. And we do this by using this equation. Activity equals the number of decays divided by time, which we measure in seconds. Okay, remember that activity is measured in becquerel. Now, we can also work out count rate. Now, some of you may be able to rearrange that equation to work out the count rate, but if you can't, here is the equation. So count rate equals the activity which again, remember, is measured in becquerel. Times it by the time, again in seconds, and that will give you my count rate. Now we're going to do some guided practice of all this new information. Before we do that, we need to spend some time embedding this information. So what I'd like you to do now, guys, is spend some time having a look at embedding this information using some whiteboards or getting your parents to test you. Okay, now just before we move on, to show you this slide quickly. This is a machine we can use to find out the activity or the number of decays, the count rate. And what we use is a stop clock at a time, and this we can then work out how active an unstable nuclei is. Okay, how fast it is decaying. Moving on, we're now going to do some guided practice. Now you've embedded all that new information. So I'm going to go through two examples together. Okay, first question. Make sure you're writing these questions down. You can write them down just as I have, or you can print off the sheets provided. Okay, so this question says, Sam records a count of 4,000. So what I'm going to do is circle the key information in 25 seconds from a radioactive source. What is it? What is its activity? First of all, it's told me I need to work out activity. So I need to try and recall the equation I need to apply. So activity equals the number of decays divided by time. And we must remember that activity is measured in becquerel. Time, we're measuring it in seconds. So now what I need to do is input my numbers. So activity equals the number of decays, or how many number of decays, how many, what's the count rate? It's 4,000. And I'm dividing that by 25. And that's going to give me an activity of 160 becquerel. And that's it. Okay, moving on. Another example. The activity of a radioactive source is 220 becquerel. So this time it's given me the activity. How many counts would be recorded in 30 seconds? So it's telling me it wants me to work out the count rate. So I'm going to apply, need to apply that equation. So count rate, the number of decays equals activity. So the activity times the time taken. Remember again, activity is measured in becquerel. I like to keep writing it out. It helps embed it into my long-term memory. Okay, and then I'm going to input my numbers from the question. So now I know the equation. That's the trickiest bit to remember. Once I know that, it's quite straightforward. So my activity in becquerel is 220, and times that by 30. This is 30 seconds. Okay. Count rate, therefore, equals, and check your answer, 6,600 counts. And that is as tricky as it gets, guys. Okay, so make sure you've got this down. Now we're going to move on to some independent practice now. It's really important that you set your answers out exactly like I have. And that's writing down the units as well. It's really important, and how to embed this information into your memory. Okay, so now let's have a look at the independent practice questions I would like you to have a go at, please. So here's the first slide. Pause, write down the questions if you don't want to print them out, or you can print them out. And here's the second slide. Now please remember to set your answer out exactly like I have. It's very tempting to just write the answer, but that's not embedding this new information, new units, and new equations. And finally, our final question. Okay, guys, thank you very much for listening today. It's still a bit rainy today, unfortunately, but hopefully it'll brighten up soon. I look forward to seeing your work around this, and I will speak to you next lesson. Thank you very much for watching.